Okay, so input-output analysis is the concept we are tackling today. And this one, it's a concept which is the application of matrices in business. And previously we have done Markov analysis, so today we are going through the input-output analysis, where we said it is a technique used to analyze the flow of the inputs and outputs in an economy, and it is based on the assumption or the concept that there is no sector in an economy that can operate in isolation or alone. So what is produced by one sector, it is used by the sector itself plus other sectors which are in that economy which are also producing, and also the non-producing sectors. From there, you need to understand some of the terms used under this concept. And the first term you need to understand is the intermediate demand. So intermediate demand is the demand from within. Meaning demand from the producing sectors. Then you need to know what we call final demand. Final demand, this is demand from the non-producing sectors. Then another term we need to get or to understand is what is total output. Total output, we said it is a combination of the intermediate demand and the final demand. So this is the combination of the intermediate and the final demand. So this one you need to understand them. Then you need briefly to know about maybe the assumptions under this concept. And one of the main assumptions is that the sectors are countable or they are finite. Then another thing you need to know is that total output or total input is equal to the total output. Then the person who came up with this model is called Leontief. So Leontief said one thing: let the total output be the combination of the intermediate demand and the final demand, and he used what X for the total output. So Leontief said total output, because in a question will be asked about the total output. He said it's a combination of the intermediate demand plus the final demand. So he said let the total output be X. Then the intermediate demand be XA. Final demand be D. So X, if X is the output here, if you want to know the formula, you need to make X the subject. The formula now to get the total output, make X the subject. So when you make X the subject, what will happen? We'll have X then minus XA. This deal will remain on this side alone, so this one has changed the side, it has become a negative XA, then it's equals to D. This XX, common factor it out, common values, so you'll have 1 minus the A, so that X times 1 is X, then X times A is minus XA is equals to D. And from there, if you need X, so you need to divide both sides by 1 minus A, 1 minus A. This one will cancel out. So X will be equals to D over 1 minus A, which you can rewrite as D into bracket 1 minus A raised to power negative 1, meaning inverse. So what is this D? Where D is the final demand. This 1 is the identity matrix. It's important to know what is an identity matrix. Identity matrix is a matrix whose primary diagonal elements are 1 and all the other elements are 0. Then you need to know about A. A is the technical coefficient matrix. A is technical coefficient matrix. Then you also need to know what does it mean by 1 minus A. So I'll have it here. Again. Let me write there 1, because we have said 1 minus A. This gives you the Leontiff's matrix. 1 minus A raised to power negative 1. This is the inverse of Leontiff's matrix. Leontief is the person who came up with the model. So this is what you want to know. So never forget this formula of forgetting the total output, that X is D into 1 minus A raised to power negative 1. You'll have to know this is the final demand. This one is the identity matrix. This A is the technical coefficient matrix. Then when you put this one under the bracket, it means this is inverse. So this 1 minus A alone, it gives you the Leontiff's matrix. Then when you put it raised to power negative 1, it is the inverse of the Leontiff's matrix. Remember the steps of coming up or determining the inverse of a 2 by 2 matrix. Steps for coming up or determining the inverse of a 3 by 3 matrix. If it is a 2 by 2 matrix, we said the first step you must obtain the determinant. After getting the determinant, it is inverse definition. And we said for the determinant, what you need to do, it is the difference between the product of the primary diagonal and the product of secondary diagonal. Then, if you want to get the inverse of that matrix, if it's a 2 by 2 matrix, you need to interchange the primary diagonal elements. Then you change the signs of the secondary diagonal elements. Then you multiply that matrix by 1 over the determinant, because inversion is like division. So that is why we are dividing by the determinant or multiplying by 1 over the determinant. Great. So we can look at a question, a CPA past paper question, one of the latest questions under this concept, which is November 2019, question number 1C. So November 2019, question number 1C, November 2019, question 1C. November question number 1C of November 2019. So the question reads, a small economy has 2 sectors, X1 and X2, producing a single product for their internal and external demand, and it is in units, as summarized in the following transaction matrix. So I'll have to write what we have given there, because I know maybe you not have this past paper, but it shall be there. So we have the production sector, so you're given this is what the examiner has given in the table. The production sector. We have production sector X1. We also have X2. We have the purchase sector, and we have again X1, X2, and also X2. Then we are given the consumer demand, and then we have here 500, we have 600 there, we have 800, we are given again here 1400. The consumer's demand is the final demand, so we are given 200. We are also given 400. Now, this is what you have been given. Then you're told the projected consumer demand changes. So it changes to 400. So the consumer's demand changes. So we are given the consumer's demand, which is changing to 400 units and 800 units for sectors XY. No, X1 and X2. Those are the consumer's demand. Now, in this question, the required part at all, the required gross output of each sector in order to meet the demand, meaning the output for each sector, and remember our formula to get the total output. But before you get the total output, with this information, you need to get the technical coefficient matrix. Technical coefficient matrix, we get it from after getting the total output. We say the total output is equal to the total input. That is one of the assumptions. This is what is going to be purchased by these sectors. This is what they are consuming. These are their inputs. So the input is equal to the output. And we said the total output is a combination of the intermediate demand, which is the demand from the sectors producing. We only have these two sectors which are producing X1 and X2. And then plus the final demand. Final demand is the demand from the non-producing sectors, like the final consumption. Those who consume the final product, those are the final consumers, and they just make part of the consumer's demand or the final demand. Now, for X1, if you want to know what was produced by X1, because out of that production of X1, 500 units were used by that department itself, which is X1. X2 used 800. And also then those who are not producing the final consumers or the consumers demand is 200. So what was the total output for this X1 department? It shall be 500 plus 800 plus 200. So this is a total of 1500. That was the total output. Because total output is equal to the total input. Come to X2 department. What it produced, 600 was purchased or consumed by X1. X2, 1400. Then final consumers, 400. So what was the total output from this sector? Shall be 600 plus 1400, which is 2000. Plus 400, which is 2400. Now you need to remember this. Technical coefficient matrix, it relates. You shall be comparing the output of a sector compared to what the sector has inputted or has consumed. For example, this is the first sector X1. The total output was 1500 units. It has consumed 500 and 600. So to get the technical coefficient matrix, you shall be dividing the consumption by the sector with the total output of that sector. So it shall be this 500, you shall be dividing it by 1500. So it's like when you put 1500 under this one, because this is for X1, total was 1500. These column values, you shall be dividing them by the 1500, which is 500 and also 600. Divide this one by 1500. Come to this sector. What is the output? This sector 2, X2. The output is 2400. So the column which shows the inputs shall be dividing everything there by 2400, which is the output of the sector. So this will be 800. You divide by 2400. 1400. You divide by, again, 2400. So you simplify this one and you'll get your technical coefficient matrix. So that's how you'll get your technical coefficient matrix. This is your A. So simplify that one. I can simplify this one very fast here. I can simplify this. I'll have a 500. I divide this one by 1500. I can see it's 0.33. I'll use two decimals. 3 is recurring. Then 600, you divide by 1500, it's coming to 0.4. You can use any single zero. You'll check 800, you divide by 2400, 0.33 again. And it's two decimals. Then 1400, divide by 2400, you'll get 0.58. So that is the technical coefficient matrix. After getting the technical coefficient matrix, you need to get the Leontiff'S matrix. You need to get the Leontiff'S matrix, which is 1 minus A. Which is 1 minus A. So let me wrap this part here. I hope you have it. So we shall have this one as Leontiff'S matrix is the next thing we need to get. Leontief's matrix, which is 1 minus A. 1 we see it is the identity matrix. And if this technical coefficient matrix is a 2 by 2, again the Leontief's, the identity matrix should be also a 2 by 2. Because for you to subtract, because this is 1 minus A, these are two matrices here represented. Then, for you to subtract two matrices, they must be of the same order. Now, this is a 2 by 2 matrix, so your identity matrix should also be a 2 by 2. And we said identity matrix, primary diagonal elements is, they are 1s, this is the primary diagonal, these elements are 1. The others are zeros. So it shall be that is the identity matrix, then minus the technical coefficient matrix, which is our A, which is here, we have 0.33, we have 0.33 again, I think, yeah, 0.33 here, 0.40, and then 0.58. Let's see it from this matrix here. Let me just, this was to just explain that this is the primary diagonal, and the values of primary diagonals, all of them are 1, the others are zeros. So subtract these two matrices, you shall have 1 minus 0.33, this will be 0.67 if I'm not wrong. Get 1 minus 0.33 is 0.67. 0 minus 0.33 shall be negative 0.33. 0 minus 0.04 is negative 0.40, not 04. So 0 minus 0.40 is 0.40, but negative. 1 minus 0.58 is 0.42, I think. 0.42. And that is how you get the Leontief's matrix. From there, get the inverse of that matrix, because we must get the inverse of that matrix. So let's get the inverse of the Leontief's matrix. Then, for inverse of a 2 by 2 matrix, you interchange the primary diagonal elements. So you shall have 0.42 there and 0.67. I've interchanged these two. Change the signs of the secondary. So here is negative 0.33 shall be 0.33. Then we have negative 0.40 shall be now positive 0.40. Multiply the matrix by 1 over the determinant. Multiply the matrix by 1 over the determinant. So you need the determinant. That is what we should have determined first, the determinant of this matrix. So let's first get the determinant, which is the product of the primary diagonal minus product of secondary diagonal. So it shall be product of primary is 0.67. I know you have done that one, times 0.42. Minus secondary is negative 0.40 times 0.33. So give me that determinant. It's coming to. Let's first get the determinant. So step 1, we need to get the determinant, then the inverse definition. So the determinant is what we want to obtain here, 0.67 multiplied by 0.42. So that one, then less. The secondary diagonal is these ones, negative 0.40 multiplied by negative 0.33. So this one is giving me 0.1494. So after you get the determinant, after getting that determinant is when now I said you do this. This was the first step there. Then after that, the second step is when you need to do the inverse definition. Inverse definition there. And for inverse definition, I've said what? Interchange the primary diagonal elements, which I had written here 0.42, you bring it there. 0.67, you come there. Change the signs of the secondary, which will be 0.33 and 0.40 because they were positive. Multiply these matrix by 1 over the determinant. Determinant is 0.1494. So 0.1494. So that is the inverse definition. But the question requires the output. So the total output, which you said, under Leontief's total output is equals to D into 1 minus A raised to power negative 1. This is the inverse part of it, which we have here. We need just to multiply with there by the final demand. So what is the final demand? What are the changes which are made? We are told this. we are told the projected consumer's demand, which is the final demand, changes to 400, so it changes to 400. That is for X1, and 800 for X2 sector, respectively. So this is the final demand. Multiply this by the inverse of the Leontiff's matrix. We have the inverse here. So 0.42, 0.33, 0.40, and you have 0.67. Then times 1 over 0.1494. So you need to multiply. This is a column for sector X1. This one is sector X1, first column. So first row times first column gives you the value for the X1 sector, the total output for X1. First row, first column, but don't forget to divide by 0.1494. So first row, first column, you'll get that one. First row, second column gives you again the other part, the other bit of that, which will be the X2 sector's total output. So here we go, 400 multiply by 0.42, because we multiply first row by first column, the corresponding value, but column-wise, plus 800, you multiply by 0.40. Whichever you are going to get, you need to divide that one by 0.1494. So from my side, I have 3266.398. So that is 3266.3989. Can have 8929. That is it. The whole figure there. First row, second column, meaning 400 by 0.33, 400 by 0.33, plus 800 by 0.64. 800 by 0.64. I have 644, but divide by 0.1494. Divide by 0.1494. It will be 4310. 4310.575636. So these were units, and that is the total output. That is what the question required you to do. So that is what was required by that question. So thank you. I want to give another. Yes, you have a question? Can respond to that.
That is 0.67.
Which one? This one? This 0.6. Oh, thank you. This was 0.67. Yeah, 0.67. So what it is changing this value here. So give us that value after changing that. This was 0.67, so it written 0.64. It should be 0.67. So it should be 400 multiplied by 0.33 plus 800 multiplied by 0.67. So this is coming to 668 divided by 0.1494. You're getting 4471?
Yes.
Yes, thank you. 4471.21820.6 units. So that is what the question requests. And it was 6 marks. So it's a simple concept. It's a simple concept for a person to grasp. So thank you so much. Let's meet in our next class.